So um, there is about an hour and 51 minutes left, and the only reason why this is not shorter is because allows for problems with installation. Allows you to quickly go and get a computer. So we're going to take the next 20 minutes or so to install this software, and then we can continue with the class because we're going to use the stuff. We're going to use MongoDB in this class, and so yeah, it's so please download MongoDB and also download the shell. The links are there, and you have 20 minutes left. And at 7:30, I am going to start grading it at 7:30 actually. So, okay. Any questions on what you need to do? Okay. If you understand, can you raise your hand so I know that I'm actually communicating? All right. Only 5 people? Okay, good. All right. So let's go install MongoDB and take a screenshot and upload that, and it's free 10 points, right? Easy 10 points. So let's go do it. And you can put your hands down now. All right. You should have installed MongoDB by now. So I can see that not many of you have submitted this. I can actually only see 5 submissions. Right. So only 5 people have done 12 submissions. I can see. So if I don't grade you right now, I'm going to take away 2 points for every 5 minutes you're late. And okay. All right. So I would grade the people who have kind of turned it in on time right now. Please make sure you're not getting the screenshot for your friend because you know that that's going to cost you 2 assignments. If I find out later that it wasn't your computer, I am going to give you 0 on every assignment, 2 assignments before that and 2 after. So this one actually will cost you 4 because I warned you before. So you're not going to fool me. You're just going to cost yourself 40 points, which is an automatic F. All right. So if I've not graded yours, it means that I'm going to penalize you for turning in the work late, right? It was due at 7:30. But you can continue to install MongoDB and turn it in at by the end of the class. After the end of the class, then you're gonna get 0. Yeah. So anyway, do your best. The point of this is that I noticed that some of you come to class quite late, and that's not acceptable. You should be here at 7 o'clock, even before 7 o'clock. So this is why I didn't tell you that there was going to be a quiz, because you have to be here on time. You have to be here when class starts. So every time we have to wait. So we can't keep doing that. That's just that's the point of that. Right? So come to class on time, and because there could be a quiz at the start of the class. Moreover, when you don't come to class on time and you miss a portion of the lecture, yeah, you don't get to ask questions. Yeah, you shouldn't miss any part of the class. All right, good. All right, so today we're going to be talking about NoSQL technology called MongoDB. And we've spent some time discussing relational databases, right? With our canonical, our reference database in the RDBMS has been SQL Server. And last time we worked on writing stored procedures, views, and just being able to kind of program in SQL, right? So we have 10 problems in the homework that allows us to even exercise that ability even more, but including writing the GPA program, right? And also being able to calculate descriptive statistics from our data using functions that are already available in SQL Server or MySQL. And so we are essentially decently proficient in being able to kind of implement solutions using SQL. So we're trying to look at the other functional analog of relational databases, which would be the NoSQL or the kind of unstructured collection of data. Unstructured in the sense that the functional analog of a table in the NoSQL world would be a collection. But unlike a table that has a rectangular shape, right, you have every row in the table has the same attributes. In the collection world, in MongoDB, every entry, every record in the collection, right, every document in the collection, that's the precise terminology. Every document in the collection may be different. They may not have the same attributes. It is not particularly rectangular in nature. It is a collection of Bison documents, right? And Bison is the way you store JSON in MongoDB. So JSON is short for JavaScript object notation, which is essentially an object literal that you've described in JavaScript. So you can think about this as a sequence or a combination of related key value pairs, right? That describes an object, and you are now saving this to MongoDB in the form of Bison. And this could take on essentially any shape you want. So every document in the collection could have related attributes, or there could be no intersection between the attributes in the documents that you saved in the collection. All right, so of course, it makes sense for us to begin at the beginning and examine CRUD operations in MongoDB. Anyone wants to remind us of the meaning of CRUD operations generally? Anyone? So nobody knows CRUD. Maybe I should take away 2 points from everyone for not knowing what CRUD operations are, since we're supposed to be good in SQL. So -2 from the class on the homework for not knowing CRUD operations, or maybe you know CRUD operations and you're not saying it. So which is it? All right. Maitran, can you please tell us what CRUD operations are?
So CRUD operation is create, read, and update and delete
All right. That's
for
correct.
storage. Thank you.
So that's correct. Regardless of the database technology that we're referring to, CRUD operation is create, read, update, and delete. So these are the basic operations that you can perform against the data store. So my trend would have no penalty in the homework, and everyone else in the class would get -2 for not knowing what CRUD operations are. So like I said at the beginning, you have to interact in this class, right? You have to be agile, and because it's going to get progressively more difficult, and it's not acceptable to keep quiet and not participate. You have to participate. So my trend gets escapes the penalty, and everyone else gets -2 for not knowing what CRUD operations are. But like she said, CRUD operations are create, read, update, delete. These are the 4 canonical or the 4 fundamental principal operations that you can perform against the data store. So we know how to do this in SQL. At least I thought we know how to do it because we ran the queries a number of times in class. So in SQL, we would say, create table, right? We would then, select from the table, right? And then we would insert into the table, and then we can update the records in the table, and then we can delete from table, or we can drop the table. All of these are the realizations of CRUD operations that we can perform against a SQL or a relational database. So similarly, we're going to start from this. We're going to start from this idea in MongoDB. Before we get started, I will show you how to get set up with your MongoDB installation. I know you follow the installer, you've clicked the buttons, and now how do you get going? All right, so let me show you what my computer looks like, and then I will show you how to get going with the MongoDB shell. All right, so if you've installed MongoDB, then you probably have now what we call the MongoDB compass. And the MongoDB compass is like an IDE that allows you to program against your MongoDB server, which you have installed during the process of installation as, in fact, a service, right? So, and I will kind of show you this if you have Windows, this will be easier to see. So if you run services.msc, which will show you a list of services running on your computer, you can actually see the MongoDB service. All right. So in Windows, if you take a look at your services.msc, and it's of course sorted alphabetically. So if you go to M and you keep going down, you would see MongoDB server, and you can see that my MongoDB server is running, right? So it is not magic. There is an actual service that is running on your computer right now post-installation that would be responding to the queries that we're going to be writing. So this is how, of course, things would work. All right, so suppose that I wanted to connect using MongoDB Compass. One of the things you would immediately see is this URI, which is also called what? The connection string. The connection string is the string that contains information on how you can connect to a data store. In SQL, right, we didn't particularly see the connection string because it was kind of done for us since we had SSMS that kind of connected to the database for us using Windows authentication. So it wasn't a big deal. If we were connecting to SQL from, say, Python, we would have to specify, in fact, in like this, the connection string. So this is what the connection string, of course, looks like in MongoDB. And this would be important for us. Since we're not going to be using MongoDB Compass, we in fact are going to be using MongoDB Shell, right? It makes it a bit harder for us to do it this way, but it makes us think about what we're doing, right? It allows us to have a more intuitive knowledge of the queries, right? Of the MongoDB queries. So we have a bit closer to how these things work by working on the shell. All right, but definitely, if you forget what the connection string should be, you can simply come and copy it from MongoDB Compass, and that would be the extent of this tool, right? The IDE in the MongoDB section of the class. We're not going to be using this at all. But once you get proficient using the MongoDB shell, then you may use this later on in your work. All right, so this is the other thing that we downloaded called the MongoDB shell, and it's this zip file, and it's, you don't know what to do with it. Well, you would need to extract it first of all. And I am going to extract mine to a folder called Mongo Shell. And I will click on extract, and you would see that a folder called Mongo Shell is going to appear on my desktop. And inside of this folder called Mongo Shell, there is this thing. And well, I'm this thing because there is only one subfolder, right? It's the Mongosh. There is a version number and Win32 x64, something like that. We're interested in the bin directory, and inside of the bin directory, you have this thing called the Mongo shell, or Mongosh, but it's the Mongo shell. And if you double click on it, it should essentially run the shell. So of course, Windows might try to say that we don't know what this is, so don't run this, please. But it's perfectly safe, as you have observed. We downloaded this from the MongoDB website. So this is a perfectly safe program. So I will click on run anyway. Yeah, because this is a safe program. And now I have the MongoDB shell, right? So you can customize the appearance here. And what I'm trying to do particularly is see if I can increase the font size. Or I can just do Control plus and see if that works. And in fact, that works, so that you guys can see this well. Okay, so now we're in full screen mode. And all right, so if you press enter, it will use the default connection string, and you would get something that looks like this, right? It would give you this: I am connecting to MongoDB using this connection string MongoDB / : //127.0.0.1, which is essentially localhost. And there is a port number, which is for any TCP connection, you need to specify a port. And the port for MongoDB is 27070, right? So that's that. So yeah. And in fact, I think you can exit the shell by just typing exit, and then I can come back to it like so. And so MongoDB /localhost would work here. You can also do 127.0.0.1, and then you specify the port 27.0.17, right? You can enter, this is the default connection string, and in fact, it's the connection string for the MongoDB service that is running locally. You specify that you hit enter, or you can just hit enter and it will just work the same way. Okay, so we know how that would work. So how do we get started? Well, the first thing I would like to tell you is, how do you know what's on your MongoDB server? On the SQL side, what we're used to doing, of course, is we have an enumeration, right? That's, in fact, so what we would do is we would click on this plus minus button on databases, and that's going to tell us the databases that we have on our computer, right? It would tell us I have BA64, I have ISC3420, 4310. These are the databases that I have. This is what we're used to when we're working with SSMS on SQL Server. So how do we do something like this in MongoDB? How do we enumerate the databases that we have? In fact, it turns out that in MongoDB, it's a bit more intuitive. So the command is show DBs. And this now tells us that by default, I have these databases that just comes with MongoDB, admin, config, and local. And this is kind of very similar to SQL Server in some sense, because you have in SQL Server system databases as well. And if you expand system databases, you would see that you have master, you have model, you have MSDB, TempDB, and these are essentially databases that come with every installation of SQL Server. All right, so similarly, you have that with MongoDB. So the next question is, how do we create a database, right? We already have a working definition for databases. Our database essentially is a collection of tables, right? And we know that a table essentially is, for us mathematically, kind of looks like a matrix, right? And every record in the table is a row vector, right? In the class where we talked about the mathematical representation of data, we in fact learned all of this. So how do we create a new database, right? How do we do this in MongoDB? We know how to do it in SQL. In SQL, we simply right-click on databases. We click on new database, like so. And what happens? We fill out the information. We give it a name. And this is what we do. We would say, hello world. And we will click OK, and a new database will be created for us called hello world. And there will be some structure, some canonical structure that comes with that database, right? As far as SQL Server is concerned, or MySQL or PostgreSQL is concerned. All right, so how do we do that in MongoDB? Well, it turns out that it's even simpler. In MongoDB, the way to do this is this use keyword, right? You can use a database that you've already created, and you can also use a database that you would intend to create. So, so let's use BA64, since that's what we have on the SQL side. And immediately I said use BA64, you can see that it said switched to BA64. The question then is, do I have database created like I would in SQL Server already? Well, it turns out that the answer is no. I don't have a database created at this point. In fact, if I say show DBs, you would see that BA64 is not listed as a database on this MongoDB server because it is not realized yet, right? It is still kind of in progress, if you will. Why is it in progress? Why is that a useful way of describing this? Well, because it doesn't have any collection yet. It doesn't contain anything. It's somewhat of an empty set, right? So it's somehow you can think of BA64 as already existing implicitly in MongoDB. Any database of any name has some sort of implicit existence in MongoDB. It only gets realized when it has a collection. So immediately where you create a collection inside of a database that you have aliased, then it gets fully realized. Then it takes on some actual realization on the MongoDB server. So yeah, it's kind of a bit different, but I suppose it kind of makes sense with your NoSQL paradigm, right? To not realize a database until it contains a collection. It makes sense in the paradigm. All right, so let's, of course, go ahead and create the first collection. And like I said before, a collection is a functional analog of a table in SQL, right? So let's go back and look at SQL Server. And so when we created our BA64 database, the first thing we did was to, of course, enumerate all the tables that we had. And at that time, there was no tables at all, at least, and no user defined tables. We had system tables, right? So at least we had a folder structure created, but there is nothing inside of it. And we have file tables, also nothing inside of it, external tables, and again, nothing inside of it. But this structure was kind of created inside of tables for us, but there was no actual table that was in there, right? No user-defined tables created. So, and the first one we created was students. So similarly, let's go and create a collection in this BA64 database and called students. So the question is, how do you do this? Well, first of all, you begin with DB. So DB is how you refer to the current database that you are in, right? So you say DB. Then on that reference to the database, you call a function called create collection. So the first thing I would like to point out here is this thing called a camel notation. You can see that this function, by convention, follows camel notation. Camel notation means that the first character of the first word is small letter, and the first character of the next word is capital letter. So it looks like a camel. If you've seen a camel before, the first hunch back of the camel is small, and the next one gets bigger, so it's a camel. So we say this is camel notation. So MongoDB uses camel notation. So if I said find one, right, you expect that find one uses camel notation. Please make sure you are on mute if you're not about to ask a question. Create collection is how you would create collection in MongoDB. And the collection we would like to create is student. So we will type that in. And we're going to use plural form because that's what we did here on the SQL side. So we want to kind of retain the same idea, but we also show how they're different, of course. But at least we're trying to keep the collections named similarly, but of course, the data will be different. The way we're going to demonstrate the use of MongoDB will be different from the data that we have used on the SQL side. All right, so db.create collection students, right? And the way we would do this, of course, in SQL would be create table, right? Students, and then there would be a list of attributes, beginning with their name, the data type, whether or not they support nulls, and everything else we want to say about the attributes. So this is the way to do it in SQL, and this is how you would do it in MongoDB. So for those of you who can already write Python, this is, of course, a more useful. Someone's mic is on. I don't know. Anyone has a question? I imagine maybe that's what's going on. No questions. Okay. Please, if you have a question, keep your mic on mute. And if you do have a question, please ask right away. All right. So great collection. Definitely, it resonates more with those of you who can code well. Maybe it's Python or C# or Java, but you understand that this is a function call and this is a parameter, right? There's a parameter rather that is defined, and I'm now passing in an argument called students to be more rigorously correct, right? So DB collection takes a parameter, and now the argument that I'm passing right now is students. And when I execute this, it should create a collection called students. All right, so you get an acknowledgement. This is an acknowledgement from the database server saying that, okay, I have done this. So two things that will happen now is that if we do show DBs, you would realize that now I have BA64. It's been realized now. Now that it has a collection inside of it, it's been realized, and it does have a size, 8 kilobytes. So you can also enumerate the collections inside of a DB, just like we do it on the SQL side, right? You can enumerate the tables by clicking on this plus button, and you can see the list of tables there. Similarly, you can say show collections, and it will tell you the collections that we have inside of the database. And in this case, we only have students. As you can see, that's the response. All right, very good. The next thing is to begin with the CRUD operation. So how do we create records or documents in a collection, right? The technical term in MongoDB is document. How do we create a document? Well, we create a document by describing it using JavaScript object notation or JSON. So the syntax for that would be DB, which is a reference to my current database, students, which references my collection, which is the collection in which I want to create the document, dot, insert one. So again, you can see that camel notation being used here, right? Small letter for the first word, capital letter for the second word, and insert one, which kind of tells you that I only want to insert one record. And in this case, I am going to open curly brackets and close curly brackets. So this is a completely valid object literal. It doesn't have any attributes, but it's valid. In fact, I can insert this into the database and it would be perfectly fine. It is an object in the database that has no attributes, right? This is one of the triumphs of the MongoDB world. You can do whatever you want. It's kind of, you're free. You have a complete freedom to express yourself. It's very expressive. But for us, we're just going to create a student that has student ID, right? So we're going to say, our student is going to have student ID. Right? And we're just going to say the ID is 1. And this is the only attribute that we're going to specify for this student. And we're going to click enter. And again, we get the acknowledgement from MongoDB. And it says acknowledge true. And it gives us an object ID, which is kind of an auto-generated ID for every document in the collection. And that's it, right? So we know that this has been done. And this is the auto-generated ID for the document that we just inserted. So the next question is, how do we create this collection? How do we find things that we've created? Well, you do that with db.students. In SQL, we do select star, right? We would do something like select star from students, which will essentially return all of the data that we have in the students database, right? It would essentially give you this. So to do that in MongoDB, you would do db.students.find. And this will essentially return all of the records. And you can see that this record has two attributes. One is the auto-generated ID, right? And the other one is the student ID. Okay, so db.students.find is analogous to select star from, right? Without specifying a constraint, right? So in SQL, you could specify a constraint with the where clause, right? You could also specify some other kinds of constraint. For example, you could select top 5, something like that. Right? Where you can, this top 5 is a constraint because it only returns the first 5 records, right? So, but select star is get me all the documents, get me all the records from the table, and get me all the records, get me all the documents from the collection is db.students.find. So it's this find function that returns everything, right? It's a function over the collection of students and finds everything for you. So also in SQL, there is something that we in fact do when we don't want all of the attributes, called a projection. Everybody remembers projection? We have the definition for it in I think the very first class on SQL. Can anyone remind us what is the definition for an SQL projection? What does it mean? This time I might call someone. Okay. So man, man, I cannot say your last name. I'm sorry.
No worry. So, can you hear me?
Yes,
So SQL projection is like we would choose specific columns from a table and display only those columns and not the rest.
absolutely great. So let me make sure that I also exclude you from the. Can you say your last name so I can learn it?
My name is my last name is Nghiêm Trọng. My first name is Mike.
Say it again, please. You said it too fast.
My first name is Mike and my last name is Nghiêm Trọng. But
Nghiêm
in
Trọng.
Vietnam, we have the family name before the first name.
Okay. All right. Cool. I would practice offline. All right. So congratulations. No penalty for you as well for explaining SQL projections. So like Man said, SQL projection is where we reduce the amount of features that we bring back, the amount of columns that we bring back, the amount of attributes that we bring back. And we do that by simply specifying what we want. So we said it's a projection because essentially it reduces the feature space for us, right? We're not using all of the features that we have. We are in a reduced space, right? This is a kind of a mathematical way of thinking about it. By listing the things we want, we reduce space when a reduced feature space. So we could say, well, I want, for example, I only want gender, I want student ID, gender, and department. Right. So this would be a SQL projection, and if I execute this, and in fact, this is what comes back. So now instead of having all of the attributes, I have three attributes. So I'm in a reduced feature space, right? I now have, 8x3 matrix, right? Instead of a much bigger matrix to deal with computationally. All right. So we can also do that in our find. When we're doing our find, we can also do a projection, and I will show you how to do that. So db.student.find. So this function accepts two parameters. The first parameter is a document that specifies the constraints, like the where clause in SQL. The second one is allows you to be able to reduce, right, your dimension. So you can essentially not bring back all the attributes. So for instance, I could say that underscore ID, which is an attribute of, it's a mandatory attribute of every document created in a collection. I don't want to bring it back. So I would turn it off with 0, and you can include it with 1. So let's say that we don't want to bring it back. And now I would run the exact same find function, only that this time you can see that the object ID has been omitted. This ID has been omitted, and I can do the same thing, but instead of leaving out the underscore ID, I could leave out the student ID. And you see that only the object ID gets returned. So the find function takes two parameters. The first document, by document, I mean this JSON document here, or the so-called object literal. It's the where clause, right? To constrain the result set, and the other one is to do projection. All right. So of course, this naturally leads us into how do you constrain your result set? But before we do that, we should potentially add some more data into our collection, right? So let's go back here and do that. So db.students dot insert one. So I will insert another record. This time I would also have student ID because I want to have something in common, right? And it's going to be 2. And I would have first name, and it would be Tony. And I will have a last name. And it would be Jackson. And I would have gender. Ooh. And it would be yeah. All right, so this is all I want to say about this record. So as you can see that in the style here is the name of the attribute, column, the value. The name of the attribute, then colon, then the value, then the name of the attribute, and so on and so forth. So I'm going to insert this document into the collection, and you would see that I have gotten the acknowledgement. And then we would discuss, after we go to the CRUD operation, we would discuss certain characteristics of MongoDB in terms of how you install it, how it works. By installation, I mean an actual enterprise installation, the nuances of that, right? And the significance of this acknowledgement, right? Because right now it might seem redundant because you have a single node of MongoDB, And so the acknowledgement is somewhat redundant, but in an enterprise installation, this is actually quite important because we install it as a replica set, right? And so we would discuss that after we go through the CRUD operations. Then we would discuss just how is MongoDB realized in an enterprise environment. Okay, so we have indeed we have inserted the second data. So now let's run our select query again, db.students.find, which will return everything we have in the collection. And now you can see that, in fact, we have two documents in the collection. We have the first document, which essentially has only one attribute, student ID, and the necessary object ID, which is automatically generated and assigned to every document created in a collection in MongoDB. And the other document that we have, which is the one we just inserted, also has the automatically generated object ID and the student ID and also other attributes that is missing in the first document. So this is the first difference that you see between MongoDB and, well, not the first difference, the first main difference, right, that you see between MongoDB and relational databases, right? In the same collection, I have two documents, two records that has entirely different number of columns. This is not possible in relational database, right? If you select star from students, you will find out that the data structure is rectangular in nature, right? Everyone has the same attributes. It could be null, but it will still be there. Remember that we in fact gave a definition for null that really explains this. Null means the attribute exists, but it doesn't have a value. So even if department was null, right, I will still have the attribute, only that I don't have a value for it. So everyone has the same amount of attributes in the relational world. Whereas in MongoDB, this is not necessarily true. So with the example that we gave in class a few classes ago, where we talked about student ID being something that is very recent, is a consequence of being in the information age. And we talked about scholars from the old days. By old days, I mean 1,000 years ago, 2,000 years ago, maybe. They might not have this notion of ID. First, because there aren't many students, and the teachers have a very limited number of students that they have to deal with. So they just refer to them by their names, right? So they don't have to give them some kind of unique identifier. And we said that if you were trying to put those students in database today, you would have to assign a student ID to them. Why? Because the database table has student ID. So even if it is null, it will still be present on the record. Whereas in MongoDB, if I was importing the records from 2,000 years ago, I can in fact just omit the attributes that they didn't have 2,000 years ago. And this is a more correct way of representing the data in the database, because simply student ID didn't exist 2,000 years ago. And of course, I am not sure of this because I'm not alive 2,000 years ago, but I imagine that it will probably have no meaning 2,000 years ago, right? Considering that there were a limited amount of students and you can simply refer to them by their name, it would be redundant. But maybe there were certain situations or institutions of learning 2,000 years ago where they in fact had some kind of ID or an identifier. But imagine that we're strictly referring to situations where they had no identifier beyond their names. And if you wanted to digitize that in the relational world, you would have to give them this ID that they didn't have. But in MongoDB, you could simply leave it out, right? You have the freedom to not include the attribute, right? And in fact, you could query the database, right, in this way. So let's begin by trying to impose some constraints on the find function. And then I would show you how not having an attribute is actually quite natural in MongoDB. right? With the way you can impose constraints, right, in the find function. Let's begin with something more simple. All right, so I'm assuming you want to simply bring back the student with student ID 1. How would you do that? Well, you would simply say I want student ID, equal to 1, something like this. And this would find the record where student ID is 1, right? If you want student ID to be 2, this would find the record where student ID is 2, and in fact, this is the only one we have. And we could also set it student ID to be 3, and there is nothing. And in fact, nothing was returned, right? Because there is no record where the student ID is 3. All right. So let's do something a bit more fun. In MongoDB, there are certain interesting functions that you can specify within your constraint document, right? So this is my constraint document, this curly bracket. It's currently empty. And we just showed in the above query that this constraint document, I can specify an attribute and a value, and it will try to find a document where that attribute exists and the value also matches, and it would return that document for me. But what if I only want to find, for example, what if I want to find documents where an attribute is defined, right? I only want you to give me documents where I have student ID, right? Like in the case we're talking about. So I have a collection of students, some from 2000 years ago, some from 2022, 23, the more recent, in more recent times. And I'm only interested in the students where student ID is defined, is an attribute. Could I do that in MongoDB? And in fact, you can. And this is going to introduce us to functions like this, right? The way to specify a function within your constraint document is usually with this $sign and the name of the function, and then that function itself is going to take a document like so, and then within that you could specify what you want. So for us, in this case, we're interested in whether or not student ID exist. I think that I have written that incorrectly, so let's see how that should be. All right, so what happens if you forget how to, the MongoDB has well-defined manual, so you can always look up the syntax at any time you want, like for example, like this. Okay, so excellent. So in fact, what we need to do is a little different from what I did. So we need to specify the attribute first, and then we need to pass the function according to the documentation. So we would have student ID like so. This takes in a document exists. And so this will look like right. So this, I think, is the way to do it, and in fact, it's correct. Right. So you can always refer to the documentation of MongoDB quite easily and see what you need to do. So it might take a while for you to get used to it, but it's really not challenging. So you have the attribute, and then you supply the function, and then you pass in true, right? If student ID exists, I want you to bring it back, right? Imagine that I said, I'm only interested in the records where student ID does not exist. Nothing would come back because there is no document here where student ID doesn't exist. So let's, in fact, retain this notion of true, and let's only bring back records where first name is defined or where first name exists. And you can see that it only returns Tony Jackson because Tony Jackson is the only record or only document in this collection where this attribute is defined. So I'm showing you this to kind of illustrate how the presence of an attribute is natural. The presence or absence of an attribute is natural in MongoDB. MongoDB knows that your collection could be made up of documents with varying attributes. So it allows you to query your collection by just saying that, well, I only want to query for the subset of my collection where a particular attribute exists. And then you can expand your query beyond that. And the operation would be only on the subset of your collection where the attribute that you're interested in exists. Okay, good. So we know that we can constrain our result set with a document, and we know that we have this kind of functions that we can use to use to compare. So outside of exist, there are other things we can do, for example. So let's go back to student ID. Imagine that I am interested in all the IDs that is greater than 0. Could I do that? Right? And the answer is yes. So I haven't specified what the attribute of interest is. I have this operator or this function in MongoDB greater than GT. And then I can say, well, I'm only interested in student IDs that are greater than 0. And now this is my constraint, student ID greater than 0. So usually you identify the attribute you're interested in, and then you can have functions that operate on them, right? So this would, of course, return all of my records. I only have 2 of them, and both of them are greater than 0. Imagine that I said greater than 1. It's going to return 2. If I said greater than 2, it would return nothing. If I could also say less than 2, and it would return 1. And I could say, less than 3, and it will return both of my records. So you get the idea. So there you specify the attribute, and then you can have functions that operate over that attribute, right? Whether it is to check if the attribute exists, or to check check over a range of values, right? Whether it's greater than, less than, things like that. You can always do that when you're constraining your result set, right? So very similar to the where clause in SQL, where we can constrain our result set. We can use this document, the first parameter defined in the find function, to constrain our result set. And as we learned earlier, that the second document, we can use it as a projection, right? We can use it to, where did we do it? We can use it to turn on and off attributes that we are not interested in. In fact, now that we have more more than one record, we can run the projection again. So we, in fact, want to turn off the ID. And let's see how this would behave now in our new world. And you can see that it, in fact, returns 2 records for us, so 2 documents, and both of them have the underscore ID removed. So imagine that I want to turn off ID and I want to turn on first name. And gender. So how would that work? You can see that we also have 2 documents back. On the first document, first name and last name is not defined. So it's a document, it's an actual response, but the attributes are missing because it's not there. And on the second document, you can see that ID has been turned off, but he also only returned first name and last name. Sorry, first name and gender. It did not return last name because when I don't specify, when I immediately I turn on some of them, everything else is turned off by default. So now let's compare this with removing the explicit turning off of the underscore ID, and let's see what happens. You can see that we are always going to get the underscore ID, right? Because it's automatically created for us. It's an artifact of MongoDB. So even when you don't turn it on, MongoDB turns it on naturally, which is why if you don't want to see it, it is important to explicitly turn it off. So this is the difference between these 2 queries. And in fact, this actually proves, right, that we got 2 separate documents back as a consequence of this projection, only that first name and gender does not exist on the first document since it only has 1 attribute and an ID. But still it's returned, right? Now that the ID is turned on, you can actually see it. And here the ID was off and it's not as obvious, right? So that is that. All right, so you know how to insert, and you know how to kind of query using the this document is to constrain your result set and to do projection. So how would you update, right? So if you look at what we have done so far, there is a lot of, well, not a lot of, but you've seen the way that we inserted the record into the database, insert 1. So you might be guessing that maybe there is an update 1, and in fact, you'll be correct. So db.students, db references the database that we're currently in, students is the collection that we're working against, and update 1, camel notation. And you kind of probably suspected that the first parameter would be to identify the 1 document that I want to update, and the next parameter would be the update that I want to make, right? So update 1, I want to update student ID. The document where student ID is equals to 1, right? And I want to set set the following, right? I want to make the following changes. So what I would like to do is just attach some more properties to this this document with student ID 1. So I would like to attach first name, for instance. Right, and so we can make it Becky, right? And that's it. And in fact, we get this acknowledgement back where it tells us that, yeah, I got your request and I was able to find something. The matched count is 1, which makes sense because we're only trying to update 1 thing. The modified count, which the number of documents it changes also 1, which makes sense because this is really our intention with update 1. And now let us go back and look at our data collection again to see whether or not what this update looks like. So db.collections, db.students rather, .find would show us our new record. And here we go. Now we have first name has been added to this document. Now there is Becky. So again, you can see that this is quite intuitive, quite easy. If I was going to attach a column in SQL, I would have to alter the table, right? I will have to alter table and students. Then I would have to add maybe first name, then mvarchar 200. Right? This is how first of all, I will have to order the definition of the table, which would add first name for every single record, right, in the table. However, in MongoDB, you can simply attach the properties whenever you want, and it gets attached only to the document or the record that you're interested in based on your matched count. So in fact, we can go back and now we can attach last name to the same. And we can say Becky Jane, right? Or in honor of so let's use a more appropriate. Well, so now we can execute the code, and you can see that last name has now been attached as another attribute of the first document, and it has no impact on any other document. So you can kind of see that MongoDB seems quite flexible. You can almost do whatever you want. So in some sense, if I went back and I executed some of my old code, this, for example, this SQL projection, all of a sudden, it's working in a different way because first name is now defined on the first document. You can see that it's now coming, it's showing it, right? So if, in fact, let's turn off the ID so that we can see this clearly. So you can see that now my query return result set, it's different because the first document now has first name defined, and as such, it brings back a document with first name defined and a value. So this is some of the triumphs of MongoDB, this kind of flexibility. And we know how to create now, we can update. And the next thing would be, how do you delete something? And you might be guessing that, well, is there a delete one? Well, you guessed it. Of course, there is a delete one. So you only need to kind of understand this insert one, update one, delete one kind of idea, and you know precisely how to work with MongoDB. There is nothing to actually forget. Insert one, update one, delete one, find. They are all kind of natural. And if you forget how to use maybe the exist or the set, you can easily look it up. As you can see that the API is quite easy. And for me, I could see the definition. It says the field first, then the operation would operate over the field, and then there is a Boolean here, so true or false. So this tells me precisely what this should look like, and I'm able to immediately fix my code. So my point is, you don't have to memorize anything. You just have to have an idea of how it works. And if you forget how something is written, you can easily look it up like so. The syntax would be given like this, and you know precisely, you would just correct it straight away. So, all right. So back to where we're doing. But in this case, there is nothing to forget because all we have to do is to specify a match predicate using our document. And in this case, we want to delete the student ID one, right? Sadly, we're going to part ways with our first student, and it also gave us an acknowledgement, acknowledge true, and the delete count is 1. And now if we go back to our database and we run our find function, it should not return student ID 1 anymore. And in fact, student ID 1 is gone. So this is essentially a basic description of the MongoDB API using the command line. You insert 1, you can update 1, you can delete 1, and all of it using the match predicate that you insert or you describe with the JSON document, right? So in this case, this JSON document, which is essentially an enumeration of attributes and the values that you want to use to match, right, the record of choice. Well, so far so good. I have shown you how to insert 1, and you're beginning to think, if there is insert 1, it probably is reasonable to expect that there will be something called insert many. And in fact, you will be correct. And so let's go and try that. Well, something is right. So db.students dot insert many, camel notation. Now, here is the first difference. Immediately you say insert many, the MongoDB API would expect an array of documents, right? So you have to immediately specify an array, which is the square brackets. And now your documents, which is your curly brackets, 1, 2, right? Or just even 1, it doesn't matter, right? As long as it is in an array, your life is easy. So in this array, we're going to define a new record, and we're going to say, well, we would insist that this record has student ID, and it is 1, which recreates the document that we just deleted. And the first name would also be Becky. So welcome back, Becky. And the last name would be Wen. And welcome back, Wen. And we would now have, we can have more attributes now. This time we could have gender, email, and in fact, we could do something more. We could have height defined here. Height in centimeters to be 165 centimeters. And then, just to make it obvious, we would have another document, and we would also define a student ID. Of 3. And that's all we're going to specify in that document. And now we'll click enter. And you can see that we got an acknowledgement back, right? And in our acknowledgement that we got back, we in fact have 2 object IDs to match the 2 documents that was created for us. So now when we go and we run db.students.find, we have 3 documents, right? We have student ID 1, student ID 2, and student ID 3. And we can, quickly update the one with student ID 3 and attach extra properties. So first of all, we have to match, and we would match on student ID 3, student ID 3, and then we can now in the document to set, we can now of course set, which also takes document from us, and in this document we would specify maybe first name. And in honor of Mang, we would use that. And last name. Would be when. Because that's the only one I can spell correctly. All right, so we execute this and it matched and it modified based on the acknowledgement that we got back. And now we could run db.students.find again, and you can see that we have a more updated result. So of course you are thinking, well, if I can insert many, can I update many? Well, you will be correct. And the syntax remains the same. db.students.update, well, at least follows the same convention rather. Update many, and you're going to give us a way to match this, right? So in fact, in this match, we would specify student ID, which is going to take a document from us, and in this document we would have a function that just compares every student ID with 0, and when it's greater than 0, it would be a match, and then we can, of course, in this document we can set an attribute for all of them, right? So we can set, for example, weight in centimeters, and it would work for everyone that matches based on the match predicate that we provided in the first document. So weight in centimeters, and maybe we'll provide a default value of 0. And we can execute this, and as you can see that it matched 3 records, because we in fact have 3 records where the student ID is greater than 0, and it modified 3 records. So let's see what our student collection looks like right now. In fact, everyone now has an attribute weight in centimeters, which is 0. Of course, 0 here means that, functionally it means there is no value because nobody weighs 0, right? Every matter has an associated weight on some scale, even if it's on the quantum scale, right? So, all right, so, and we can now potentially one by one, after since we've kind of done a mass update, you could update one and identify a particular student ID. Another thing is it's difficult to make inline changes on the command line. Yeah, so that's one disadvantage. But you can identify as an ID 1, and now you can, you can set the weight in centimeter. Oh, there is weight in centimeters. No one said anything. Yeah. There is no there is this is an attribute that makes no sense. It's weight in pounds, but I said weight in centimeters, right? But anyway, so we can set the value for each and every one of them, which you already know how to do. There's no need for me to do this. And so we can insert many, update many, and that's the key idea. And one thing to also note is bulk updates are usually good for attributes that are somewhat uniform. At least something that you can, like, this assigning this attribute and a value of 0 to all of my records. It's not particularly useful in MongoDB since I can do it one by one anyway and just attach the attributes. So it's always kind of useful when your match predicate identifies a set where the attribute is actually uniform, right? For example, if there is a way that you can match students that is maybe shorter than a height, and then you can set an attribute not in the basketball team, something like that, then update many would be useful. But you would find that most of all, you are kind of you're kind of using update 1 as the more useful function. All right, so to kind of finish the lecture for today, you guessed it, we can also delete many, right? Just like we've done before. We're going to delete where student ID is greater than 0, which essentially deletes every record in our database. All right, we have a missing curly brackets. So another downside sometimes of the command line is that you might not really know. The error message might be somewhat not helpful, although it's kind of pointing out where the curly brackets was missing, but it didn't select the right symbol. It said expected comma, right? But what was missing was a curly bracket. So that could be confusing. So anyway, I would say that as a general rule, just make sure that you open and close the curly brackets correctly. And if you don't, and you see an arrow like this with an arrow at the end, is usually just saying that you have an open curly bracket that you didn't close. So again, we have the acknowledgement and we have 3 records deleted. And if I go back to the database and I do db.students.find, we in fact have nothing left, right? So yeah. And just so that we have something there, I've inserted something back into the table. Rate in pounds this time. And now if you do db.students find, now you have something in there, right? So, okay. Any questions before we go? Any questions before we go? Next week, when we come back, we're going to focus more on the aggregation pipeline for MongoDB. And that is a bit, it's a bit more complicated, but it allows you to kind of have the same power that you would have with stored procedures, if you will. Well, maybe not the complete expressiveness of stored procedures, but you could do more with the aggregation pipeline in MongoDB than just these basic operations, right? So you can chain things together. This is why it's called a pipeline. And so we would try to do some of the things that we're already doing with the usual easy API. And we would do that with the MongoDB aggregation pipeline. But before we even do that, we're going to kind of explore how we can chain functions together, right, in MongoDB. This is where we're going to start. Chaining functions together, how you can, because right now, so far, we have executed a single method or a single function against the students collection, even though we could have multiple parameters. But in MongoDB, you can also chain functions together. So we'll start by chaining functions together, and then we would move into the aggregation pipeline next week. So any questions so far? Please ask questions, because if you ask a good question, I might give you 3 points. So if you feel like you don't have enough points in the class, yeah, by participating more in the class, asking questions, interacting, I would for sure give you points, because it helps everyone, right? When you ask questions, other people have more confidence in asking questions. But if no one asks questions, then it becomes a class where we don't ask questions. Okay, Mintran, what's your question?
I just wanna ask if, like, do we have a way to change the name of the attribute that we created? Like, for example, before I accidentally created the attribute student ID, but I add another S after the student, so I want to change it back, like similar to your example, but I don't
Right.
know how, so I only have I can only like delete it and recreate the new one. So I want to ask
So
if we have another way.
that's a really good question. So yeah, I mean, great idea, right? Great question. Of course, yes. The answer is yes. We could modify the attribute names. So, and you would see how we would do this using the aggregation pipeline. Once we get started, in fact, it will be one of the examples that we will use. It would be really sad if we could not modify the attribute names, but we can. But in this simple examples, you can just delete and recreate it again. But once we get to the aggregation pipeline, then yeah, it would fit right into that model for us. So the answer to the question is that you would see how to do that next class. Make sense? Excellent. Okay, any other questions before we go? All right, so we would start from here next time. Like I said, we would begin with learning how to chain functions together. Then we will start with the MongoDB aggregation pipeline. And then hopefully we can work. Oh yeah, Jessica has a question. So what's your question, Jess?
Oh, yes. I have a question. Like in Python, we can connect a database to the Python, then we adjust it. So can we do similarly in the MongoDB?
Yeah, so you're kind of ahead of us there. So there is a MongoDB driver for Python, and in the MongoDB driver for Python, we can do all of this in Python code. So in
So it
fact, I
means
would
that
say,
I can,
go
sorry.
on.
So it means that I can insert the database there and I can adjust like the column and also the row and the informations inside that.
Absolutely, yes. Using the Python
Yeah.
MongoDB for MongoDB driver for Python, right? So PyMongo is the name of the library. You pip install PyMongo, and then it gives you that interface to connect with the MongoDB using the connection string, and then you can do all of this. In fact, it's very similar to this code. The only difference is that you're going to be using Python semantics. So instead of camel notation, it will be insert underscore many, right? Lowercase. Update underscore many, insert underscore one, right? Just the way you would name functions in Python. This is just the principal difference. Everything else is identical. And then, of course, the Python syntax prevails. But, the way the object literal looks close to how you would make it possible in Python and pass it around as an object, and it would just work fine. All right. I think there's another question. Dongtran, you can ask your question.
I have a questions about some kind of update many or delete many, because I see that you have an example about when the student ID is greater than one, but the next parameters, the set, the result will be identical if the constraint is greater than 0, for example. So I want to ask if we can like customize the if we have student ID greater than 0, so we have student ID 1, 2, 3. So can we customize each of them?
Right. So that was what I was saying. This is a good question. And in fact, because 3 people asked questions, there is no penalty for you anymore. So this supersedes the not answering the crowd question. So thank you, Min, Jessica, and Dong for asking questions so that the entire class gets off free. So yes, the answer to your question is that, of course, updating many and setting the same value is somewhat redundant, like I said before. So you have to be able to kind of write the match predicate to really identify a subset in your data where the actual attribute is uniform. Imagine that you want to say that some groups, you want to identify subgroups, and you want to give the subgroups maybe group A, group B, group C, group D. This would be fantastic for that. So you would have the constraint for matching group A, right? You would write that in the first parameter, and then you would set the group number to A, and everybody would have group A, and then you will match group B and set the group number to B and things like that. So this would be a good use of update menu. Does that make sense, Dunk?
Yes, thank you.
All right, excellent. I think Dong Hong, you have a question? Please go on.
Okay, can you hear me?
Yes.
So after I execute the code, db.student delete many, is there any code that recover the record I have deleted, like undo the execution, delete many?
No, you can, once you delete many, it's gone. You have to recreate it again. So yeah, there is no way to undo it, I don't think. Yeah. And when
Thank you.
you have a question?
Yeah, I just wanted to ask if the file will save it by itself. So next time I open it,
Oh yeah,
it will be all the
absolutely.
same. Oh,
Yeah,
okay, thank you.
it's been saved. That's why when we started, I showed you the MongoDB service. That's what is
Oh,
processing
okay.
our query. So it actually saves a copy, it's there. Everything you've done right now, it's permanent, right? You would find
Thank
it
you.
when you connect again. All right. Excellent. Very good. Well, I will see you guys next week, and thank you for asking questions. Bye-bye.